So here we go. We're getting close to the end of section one, of chapters 1 and chapters 2. We'll be taking a test within the next week or so. I'll talk more about that in class. Here we're looking at, again, this entire chapter we've been bouncing back and forth between different sections because they kind of fit together in a different form than what they were giving us in the book. Chapter 2, Section 1, Functions and their Graphs. Chapter 2, Section 5, Correlation and Best Fitting Lines. We've done a lot on 2.5 already. We're just going to kind of fit these ideas together with functions and correlations. A function is a relation if there is exactly one output for each input. So if I look, what I'm looking at for this is I'm looking to see if I'm looking at a table, excuse me, if I'm looking at a table, I'm looking at a repeat in the x's. No repeat, no repeat, no repeat, 2, 3, 4, 5. That is a function. Now, technically speaking, it's still a relation. A relation is an ordered pair of numbers. That's all it is. It just lists x's and y's. There's no, a relation is the most generic form of putting together numbers in pairs. A function means for every x, there's only one y. If I look at number 2, I have x of 2 is going to 5, and x of 2 is going to 6. 2 is going to 2 different places, and since 2 is going to 2 different places, this is not a function. Now, just like number 1, it is a relation because all of these are relations, but number 2 is not a function. Number 3, I have a repeat in the y, but a function never says that that's a bad thing. So this is a function. It's the repetition in the x that doesn't work. A repetition in the y is just fine. So that is how I can tell the difference between a function and just a relation if I'm looking at a table. Well, what if I'm looking at something different? Let's use, if I'm looking at a graph, we use what's called the vertical line test. An equation, not a equation, but an equation is a function if and only if no vertical line intersects the graph in more than one point. For every x, there's only one x. When x is 2 here, I only get 1 point on my graph. When x is negative 6 here, I only get 1 point on my graph. There's no place on my graph where I have a repeat. So this first is a function. This second graph is a function. Both of these are linear functions. This here, my entire graph is a vertical line. So I have multiple repetition. The vertical line test, I hit the graph many, many, many times. So this is not a function. T-I-O-N. If I come over here, if I draw a vertical line as however many vertical lines I want to draw, I'm never going to hit this parabola more than once at a time. So this is a function. But in the same way, if I draw a vertical line here, I hit my graph in 2 places. This is not a function. Like I said earlier, all of these are relations, but this is just a relation. It's not a function at all. And this, the absolute value graph, this is also a function because when I go to do my vertical line test, I only hit the graph one place at a time. I don't hit it more than once. So that's the idea of deciding if a graph is a function or not. Every time we come up with an equation or a new type of equation that we're working, we have to decide, is this a function? Is this not a function? Every time we work with one of these, we want to know, because functions give us some special things that relations don't. And so at this point, I just need to know that there's a difference between a function and just a relation. That's all of Chapter 2, Section 1 that we're going to cover. Chapter 2, Section 5 is talking about correlations and line of best fit. A correlation is a scatter plot that can have positive, negative, or relatively no correlation. Positive means if I look at my data, for the most part, my data is forming a line that from left to right is increasing. So this has positive correlation. Here, from left to right, my data is decreasing from left to right. So this has negative correlation. When I look at this data, I really can't make any sense of it. I can't go up, I can't go down, I can't go vertical or horizontal. The data just doesn't go in. Ooh, let's not do that. We'll take those lines off. The data doesn't go anywhere. So since the data doesn't go anywhere, I can say that this has relatively no correlation. When I'm looking at data in my graphing calculator, how do I know if it's good correlation, if I can use it, or if it's going to be a bad model of my data? The correlation coefficient R is a measure of correlation. The closer it is to 1 or -1, the better the fit of the line. R values between 0.8 and 1 or -0.8 and -1 can be considered to be good fits. So, excuse me. If you have turned diagnostics on your calculator, you will see R and R squared when you find regression equation. So this is what I want to do. I have this data. Go ahead and pause and put this data into your calculator. But before you do that, remember, year 1989 is going to be my first year, so that's the year 0. The table below gives the number of FM radio stations from 1989 to 1995. 1989 is year 0 because that's when I'm starting. So 1990 is 1, 1991 is 2, 1992 is 3, 1994 is 5, 1994 is 5, 1993 is 4, 1995 is 6. So it's these numbers here that's going to go in my L1. These numbers here are going to go into my L2. I want to do a linear regression of this. I want to see if it's positive, negatively, or have no correlation. And then I want to know what the correlation coefficient is. Is this a good model, a good representation of this data? That's what I want to figure out. So I go to my handy dandy calculator, pause and enter in this data I already have. Pause. Now that you've paused and you've come back, I'm going to go ahead and look at this information. First of all, as I said earlier on the notes and as I was talking, you need to go ahead and turn on what is called, make sure I said diagnostics. Diagnostics on. So to do this on your calculator, I know there's a choice somewhere, but if you're not sure where something is found, down here under the 0, there's this button that says catalog. If I hit second 0, it brings up this alphabetical catalog of everything in the calculator. So I'm going to arrow down to D's, and I'm going to find diagnostics. There's one that says diagnostics off, and then one that says diagnostics on. And I just passed them both. Oops, let's go back. Calculator's behind my. So my diagnostics have been off, so I'm going to get on diagnostics on. I'm going to hit enter. I'm going to hit enter, and it's done. The diagnostics are now turned on. When I go and calculate my data, it's now going to show me R and R squared in that data. Please turn it on if you haven't already been having that come up. So I want to do a scatter plot. So I'm going to do stat. I'm going to write over to calc. I'm going to choose number 4, linear regression. I want the data to go straight to my y equals. So I'm going to hit vars. I'm going to write over to y vars. I'm going to hit 1 for function, 1 for y1. I'm going to hit enter. There's my data. There's my graph. It didn't slide over. There it goes. And notice right here it gives me an R value and an R squared value. R values are, it's just kind of a measurement of how off from my points is my line of best fit, is my linear regression line. R squared is squaring those before you add them and seeing how close of a fit that is. We want to look more at the R than at the R squared. So it says calculate the linear regression equation. So this is y is equal to 222.1x plus 4,166. State whether the data has positive, negative, or relatively no correlation. Well, let's go back to our calculator. If I hit graph, I don't see anything because I have a bad window. If I go to window, my x's went from 0 to 6. So I'm going to make mine go -5 to 10 so I can see all of those points, count by ones. My y's go from 4,269 to 5,730. So let's go from 4,000 to 6,000. I'm going to count by 100 so I don't have too many dashes down there. And when I hit graph, there's my data and there's my line. Looking at the data, I'm going to come over here. If you get on the equal sign and hit enter, the equal sign is no longer highlighted. So that means it's not going to draw the graph. Look at this data. Is this positive, negative, or no correlation? If I look at this graph, that I can see from left to right, my data is increasing. It's almost linear here. Then I have this one point that makes it a little different than just linear. So it definitely is a positive correlation. As x increases, y increases. A negative correlation would say as x increases, y decreases. So that would be a negative correlation. So here I have a positive correlation. What is the correlation coefficient? Well, as I stated earlier, my correlation coefficient, we'll get over to that, is this R is equal to 0.964657 ... Based on the correlation coefficient, do you think the line fits the data well? 1 would mean it fit it perfectly. 0 would mean it doesn't fit it at all. It doesn't make any sense. I doubt you're ever going to have anything that's that off. I think it gets somewhat close. So 0.96 is a good coefficient because it's between 0.8 and 1. So I know that this is a good line of best fit. Hey guys, that's all the information that I have for you for this video. Hopefully you got a little bit out of this correlations, the correlation coefficient, and talking about functions. Have a good day.